Greetings and welcome to my new calculus channel. So I'm John Gabriel, and today I'm going to talk about a very well-known algorithm, the one that's called the Euclidean algorithm. And I'll explain it in a way that even the most simple of people can understand it. In other words, we're looking for an explanation that one can read without having to study it for several hours and get to the bottom of it. Now, this algorithm is normally encountered by most people, and at first sight, it intimidates them because they do not understand. The Euclidean algorithm is about measure, okay? Nothing else. And of course, measure, division, let me start again. The arithmetic operation of division is a form of counting, okay? And I'll explain that in a minute. So counting numbers forms the basis of the Euclidean algorithm. In other words, it's measurement where the abstract unit is being used. So, and I'll explain that also in a moment. So the most important arithmetic operation of division is based on counting, right? And you can get a, a very simple overview by looking at my document, this document here on Academia, this PDF, Unlocking the Mystery of Numbers and Fractions. And then you could come back and read from where you left off here. Now, the Greek word for division, or the word for measure, is actually the same as division, because division means to take apart, and dia means through, across, or over, and era, to grasp or take. So the word measurement, which is matrice, appears 145 times in the element. Okay, and as a suffix, metri appears 213 times. So let's see now that I've given you some of the historical details. To count a few objects, such as those found in the illustration below, is to measure or divide. Okay, why is it to measure or divide? Well, because you're considering this to be a number and you're measuring it with 1, 2, and 3, right? So 3 divided by 1 is the measure of 3 using 1 as an abstract unit, okay? And in the second example, we have 12 cookies divided by 4 people. That's the measure of 12 cookies using 4 people as a unit, okay? So you use 4 people as a unit. Here, you've only got 1, so it's 1, 2, 3. And same story here. When you divide 12 by 4, it'll be 4 cookies once, 8 cookies twice, 12 cookies 3 times, right? So in 1, the 3 objects are measured by an arbitrary object acting as a unit. And in 2, 12 cookies are measured using a unit of 4 people. So that's the measure of counting is the measure of any object using the abstract unit. To understand the Euclidean algorithm, you really should study this brilliant article, this PDF, Unlocking the Mystery of Numbers and Fractions. Now, what is the algorithm about? It's very simple. So if we're supposed to find the GCD, or the greatest common divisor or denominator, of 12 and 20, we try to measure 20 using 12. So we say, how many times does 12 go into 20? It goes once, and there's 8 left, right? So we know that we can measure 12 and 20 using 12, but we can't measure 20 completely because there's 8 left, right? So we can measure 12 using itself, obviously, and 20 only once, okay? So 12 measures 20 once with a remainder of 8. So the next thing we do is we say, okay, well, does 8 measure 12? So 8 measures itself, but it doesn't measure 12 completely. It only measures it once with a remainder of 4. And finally, 8 is measured by 4, okay? So 8 is measured by 4 2 times, and therefore 4 is the greatest common denominator. But or divisor. Let's now try to understand this. The general idea is to keep measuring the remainder and then finally to infer that the last measure will percolate upwards and so measure the original two numbers. The original two numbers are 12 and 20. Okay. In other words, 4 will measure both. Why? Because let's go through this slowly. If 4 measures 8, so we start at the bottom, okay? If 4 measures 8 over here, then 4 will also measure 12 because 12 is measured by 8 and 8 itself. So then 4 will also measure 12 because 4 measures itself and 8, right? And finally, 20 is measured by 12 and 8. It's measured together by 12 and 8, not alone by 12 or by 8, okay? In other words, you need one 12 and another 8 to measure 20. So 20 is measured by 12 and 8, therefore it is also measured by 4 because 4 measures both 8 and 12. So since 4 measures all the previous dividers, we know that 4 is the greatest common divisor. There is no whole divisor greater than 4, which measures both 12 and 20. Do you see how easy it is to understand? So this process is quite simple, but somehow everyone who meets it for the first time feels intimidated. It's just as simple as counting or measuring, because when one divides, one inevitably counts. It doesn't matter whether you're adding up the units or you're subtracting the units. For example, you can say 12 divided by 4 is found by subtracting 4. How many times? 3. Or you can say that it's found by adding 4 to itself. So you'd need 1 4 plus another 4 plus another 4. So 3 times, okay? This article is available on Academia, and you can find it over there on my Academia page. Now, before I sign off, I'm going to place a link to the site. I know it's not going to help most of you because this academic doesn't really know English well. So all his documents, all his PDFs are in Greek. Now, although I don't agree with everything he says, I agree with a lot of what he says, and he has a very nice website, which is this website here. And over here you have the entire Euclid's Elements, all 13 books. Okay? Now, and you can do searches on this. So if you wanted to search for the word measure to see that I'm not lying to you, you can type Control F and like that and type in metrici, and it will show you that it appears so many times. So you can actually count up the number of appearances. A measure is mentioned many, many, many times in the Elements of Euclid. So this is a good link to go to. And finally, I'll place a link to this article as well. If you're not already a subscriber, become one, tell your friends about it. Don't forget to click like. Become a follower on academia.edu. I'm John Gabriel. This is New Calculus Channel. Until next time, goodbye.